The next steps for us would be basically to, um, well, we could go a couple ways here. We could start to isolate the front face and work on the facade, or we could start to develop the floor plates, which is something that's kind of new that you haven't experienced yet. Um, the first thing that I'm going to do is isolate the floor plates and yeah, hang on. Yeah, I'm going to isolate the floor plates and give them thickness, right? Because all of this is about applying architectural elements. So starting with the floor plates is going to be easiest, although ironically it's going to have the most components, at least to do it interestingly anyway. So the way that I'm going to do this is to basically break down the cap into individual surfaces so that I can select the one that I'm going to start my floor slabs on. Okay, so you can do this a number of ways. You could deconstruct it. You could go down or go back to your polyline and your end line and just kind of loft those two together to create a surface. It's really up to you. I think the easiest way at this point is to just deconstruct it and then select from the list of items which one you want to use as your starting point slab, I guess you should say. So with that, I need to isolate it using what command? List item, thank you. All right, so list item is going to allow us to take the individual faces. So we have 7 faces. We have 7 faces to this? Oh, did it split it? Oh, yeah, it is split. Yeah, that's right, because that's going to give us the problem later. That's good. So we have individual faces that we're going to select. And 0 less than, if we have 7 of them, we can say 0 less than 6 allows us to cycle through. And when you select this, it actually, ironically, right now selects the one I want, which is the base. But you can turn these off in order to kind of filter through it. So this one selected the base. I can go around and select each of the other surfaces here. But I know that for me, the way I'm going to do this is using the base plate. Now, why am I using the base plate? Any ideas about how to do this automatically? Just anything. I need you guys to be thinking ahead here. So, the process I'm going to use is to array this floor plate vertically. However, in some cases, the bottom floor might not actually extend as far as the volume itself. Sometimes a building is skinnier at the bottom than it is at the top. So if I use my bottom floor plate, it might not extend all the way to the edge of the building. So what I have to do is take that bottom surface, blow it up by a certain factor, a reasonable factor that I guess will probably never be smaller than the building itself. So I might do 2 or 3 times its size. Then array it, and then I can basically chop off or find the curve around where it intersects the volume itself, and then extrude it down into a slab. So I'm going to do that with you right now. It sounds like a lot, but it's really not. It's the same process you would use to model it physically, just now it's going to be parametric. So anyway, I've got this surface. I need to scale it up and make it bigger. So I'm going to do transform, affine, scale, and I'm just going to plug that in right here. The geometry is obviously the surface. The center point is going to be the centroid of the surface. So that's found, again, under surface analysis, like this. Plug the centroid in. And then the scale factor is really easy. All I have to do is just give it a number. So I'm going to just drop here a scale factor of 3. That makes it 3 times as large as the base of my volume. So within a reasonable boundary, I don't anticipate pulling this thing that far out to the side, because that's going to look pretty silly, although some of us have really crazy forms, I guess, in some of our design projects, but that's neither here nor there. So anyway, 3 works well for me now. And what I've got to do at this point is to really just array it vertically. And array linear, this is a new tool now. I don't think we've used array linear before, but array linear is found under, where was it? I thought it was under vector. Transform, sorry. Transform array and linear array. So like we went over the other day, since this is a new tool, we're trying a new method, I'm going to talk about and sort of research what it does. It says that it creates a linear array of geometry. So what it's requesting is obviously the geometry that it's going to array, and then it'll ask you for the same things that you need to give it in the Rhino environment. It's going to ask for the direction that it's going, and in this case it's asking for the direction and interval. So that's direction and magnitude. And then it's also going to ask for the number of elements. Okay, so I need to plug the geometry in. You'll see that it defaults to shooting it off to the side. And then I need to basically create a slider with a distance for how tall my floor height is going to be. And then I could do a slider, or I could leave it at a static number for the number. But I also need to give it the direction of Z, so vertical. It's going straight up. Now we're doing like vertical building structures. We can just use the world Z. So I'm going to use unit Z. It's going to go in here. You'll see that now it's going a default value of 1 foot vertically. I'm going to override that with a reasonable height per floor with a slider. So I'm going to go from 0 to maybe 15. Not 0 to 15, 10 to 15. Never been in a build. Wait, sorry. 10 to 15. There we go. So with my building height at 10 feet, I get 1, 2, 3, 4 floors in there. If I go up to maybe 12, I get 1, 2, 3, 4, 3.5, something like that. So I'm going to start with this for now. And then the good thing is with the number of 10 values, it automatically at this point goes higher than the building itself, which is okay. I am going to leave it there at a static number. If you want, you can put a slider on there from 0 to 10 to 20 so that you can change it later if you need to. But it should be fine there at 10. All right, so we've dropped in like 5 or 6 different components here. We arrayed the floor plate, or we scaled the floor plate, we arrayed it. What questions do you have at this point? None? All right, so let me just kind of take a lap and make sure we're all caught up before moving on.